find the circulation, which is a word for flow if we have a closed path in the plane, and flux of the vector field, which we're thinking here is a velocity field. F of xy equals xi plus yj around and across. So the circulation is measured around, the flux is measured across the closed semicircular path C, formed by R1 of t is 2 cosine ti plus 2 sine tj, with t between 0 and pi, and R2, which is the line segment ti, where t is between -2 and +2. So let's think about that closed semicircular pathway first. If I imagine starting on R1, I first trace out this arch, and then I have this line segment coming across as R2. And so that's the pathway that I'm considering. And so what I have now is this idea that flow or circulation over this plane curve can be calculated this way, and flux can be calculated this way. Well, m and n, very easy things to think about. To find dx and dy, I'll have to take some derivatives, and since my pathway here, C, is only piecewise smooth, I'm going to have to use additivity to calculate both. I'll calculate flow over the arch and over the line segment, and I'll do the same thing for flux. To calculate flux, I have to have a simple closed curve in the plane, and I do still get to use additivity. Being piecewise smooth here is enough. So I know my approach now. I'll calculate flow across the arch, across the line segment, and I'll do the same thing for flux, and I'll have to use the idea of additivity. All right, so let's write down what m is. Well, m is equal to x, but on pathway 1, that would be 2 cosine t. So on path 1, that just becomes 2 cosine t, and then n is equal to 2 sine t. Well, on pathway 1, now I can take some derivatives and tell you what dx and dy are. So x is 2 cosine, so dx is minus 2 sine t dt. Y here in the first one is 2 sine t, so dy is 2 times cosine t dt. All of that going to help me calculate flux and flow over path 1. For path 2, now the x is t and the y is 0. So that shouldn't be too hard to use in a calculation. And now dx is equal to dt. Well, and dy is, well, 0 dt. So hopefully these will help me in a minute. Let's calculate the flow and then the flux. So along path 1, I know t had to be between 0 and pi, and I'm looking at m dx. And then dt, which I'm going to write at the end when I'm all said and done here, plus, so I left out a cosine there, so, all right, well, let's just try that again. Minus 4 sine t cosine t. All right, plus n dy. Plus, and now an integral, and R2 went from -2 to 2. M dx, well, that's just going to be t dt, and plus a whole lot of nothing. Well, looking here, this zeroes out, right? The integrand becomes 0, nothing to worry about there. This one's not too bad to calculate. All right, so 1/2 t squared from -2 to 2. Well, let's see, it's going to be a 2 minus a 2, and that zeroes out 2. And so literally everything actually just zeroed out. A little bit sloppy in my notation there, so let's imagine that as scratch work, and then I have the sum of two integrals, which all did zero out. So I report that the flow is 0. Units of velocity times units of distance. All right, so the flow, everything ended up canceling out and we got 0. Now let's see if we can calculate the flux. So my approach remains the same, this time remembering the overarching theme that flux is m dy minus n dx. All right, I need to work over path 1 and over path number 2. Path number 1, t went from 0 to pi, and I have m dy. Well, that's going to be 4 cosine squared t. I have n dx. But it was a minus, so that becomes a plus, and that's like the greatest thing ever, dt. Over path 2, which went from t is -2 to 2. I have m dy. All right, well that zeroes out, and then n dx, that zeroes out. So I won't even worry about that. That all zeroes out. Well, a nice Pythagorean identity tells me that this is just 4 dt. So 4t evaluated from 0 to pi plus 0, we just get 4 pi. And so I tell you the flux is 4 times